Okay, so we've got this function here, which looks pretty ugly because it's got a square root sign, it's got integrals, it's got dx's in there, and we have to just differentiate it. Okay, so we have to find the derivative of that function. Okay, so the first thing I like to do is, like, whenever you've got square roots, you've got to kind of get rid of them. So what we really want to do is that's t to the 1 times t to the half. And also, I find this a little bit confusing when you've got a dx as part of the equation, because really what you want to say is that's the integral of 1 over 1 take x squared dx. Okay, so that's the first step. So now we've got t to the power of, what's that, 1 plus a half is 3 over 2 plus that integral. Okay, so now the nice thing about this is we've got two things that we add together, so we can just treat them separately when we find the derivative. So the derivative of this is take the derivative of the first one. So the derivative of power is you bring the power down to the front and subtract 1 from the index. So that's 3 over 2, take 1 is only a half. Okay, so that's the first bit done. The second bit is using that fundamental theorem of calculus. And the fundamental theorem of calculus, it looks a bit horrible, but let's write it down here. So the derivative from 0 to 1. So this is what we're trying to figure out. Okay, so the fundamental theorem of calculus just basically says we're going to do an integral of a function here, and then we take the derivative. Now, you're kind of doing two things which are going to cancel each other out. It's like multiplying a number by 2 and then dividing it by 2. You're going to end up with the same number. So essentially that's what we're doing here. We've got this function here, which we're going to integrate and then take the derivative of. And so basically what you end up with, so this first left-hand side stays the same, the left-hand half. So the derivative and the integral cancel out, and so basically what you're left is 1 over 1 take t squared. Okay, because we need to change that x to a t because we're working with respect to t. So that's a function. That's the answer. So you end up with that as the derivative.